all. I am Dr. V. Hemalatha, Assistant Professor of Maths. And then here we are going to study the kinetic concepts. The first one is scalar and vector. The second one is motion and rest. And then the third one is distance and displacement. And then the fourth one is speed and velocity. And then the fifth one is acceleration. First we are going to study what is the scalar product quantities. Scalar quantities are the physical quantities which is complete with a magnitude alone. For an example, mass, temperature, energy, work, pressure, all those things are scalar quantities. Now here we are going to see an example. The mass of my body is 60 kg means my body is made up of matter 60 kg. It doesn't need any more explanation. And then vector product. And then vector quantity is the one which need a direction for completing its existence, velocity, force, weight, acceleration, and then so on. My weight is 600 N means I am pulled towards earth with a force of 600 N. It is not complete unless it is specified towards earth. And then we are going to study rest and motion. What is the meaning of rest and then what is the meaning for motion? Here we are going to see an object is said to be at rest if it is not varying its position with respect to time. And then motion depends on an object is said to be under motion if it changes its position with respect to time. Both motion and rest are comparative. A table in which my room at rest with respect to earth while under motion with respect to sun. This is the example for both motion and rest. And then distance and displacement. Displacement is the difference in motion in position of the object. It is the straight line distance between the initial and final position of an object. It is a vector quantity. Distance is the length of the path followed by the object. It is a scalar quantity. Speed is the rate of change of distance or the distance covered per unit time. Speed is the total distance covered in total time. Speed equal to distance by time taken. It's SI unit equal to ms minus 1. And then next, velocity. It is the rate of change of displacement. It is a measured speed in a given direction. It tells us not only the speed of the object but also the direction. It is a vector quantity. Velocity equal to dy by dx. And then displacement. Next we are going to see the displacement d delta s by delta t. Average speed and average velocity. Average speed equal to total distance by total time. Average velocity equal to total displacement by total time. If u is the initial velocity and v is the final velocity of the object, then v equal to u plus v by 2. Instantaneous velocity. It is the average velocity obtained during an interval of time which is very very small. The slope of the tangent to the graph of the position rest time is velocity. And then v equal to limit delta t tends to 0 and then delta s by delta t. And then this is the graph for the instantaneous velocity. They take time on the x-axis and then displacement on the y-axis and then the formula equal to d delta s by delta t. Velocity time graph. And then acceleration. It is the rate of change of velocity. Acceleration equal to dv by dt. SI unit is ms minus 2. The acceleration equal to v minus u by t. This is the change in position of the velocity versus time graph. And then the answer to the above graph, the total distance travelled by the object is the sum of all the distance it travelled during the time interval. In the first 2 seconds it travelled 3 minutes, then it travelled 6 minutes in the second 2 seconds. Then over the next 5 seconds the object moved 4.5 meter. So the total distance is 3 plus 6 plus 4.5 equal to 13.5 meter. Down the graph it is travelled minus 4m. The displacement of the object is 13.5 minus 4 equal to 19 0.5 meter. The equation of motion, change in position equal to area under the curve, delta S equal to average velocity into time, V equal to U plus V by 2, and then delta S equal to U plus V by 2 into T. Substitute V equal to U plus AT, then delta S equal to UT plus half AT squared. Now this one continue, delta S equal to average velocity into time, substitute for T equal to V minus V by A, and then delta S equal to V squared minus V squared by 2A. And then the equation of motion can only be applied when acceleration is constant. Then S equal to U plus V by 2 into V equal to U plus AT, then V squared equal to U squared plus 2AS, S equal to UT plus half AT squared. And then projectile. Next we come to on the next session, projectile motion. A projectile is an object that has been given initial velocity by some short-lived forces and then moves through the air under the influence of gravity. Baseball, stones, bullets are all examples of projectiles. Projectile motion. A predictable path travelled by an object that is influenced only by the initial launch speed, launch angle, and then acceleration due to gravity. The projectile follows a predictable parabolic path. Some examples of projectiles include a baseball that has been pitched, batted, or thrown. These are the examples. A runner in mid-stride, all those things are. A moving airplane in the air which its engines and wings disabled. These are all examples of a projectile. Next we are going to see a force on a projectile. The force of primary importance acting on the projectile is gravity. The kinematic equation for a simple projectile are those of an object traveling with a constant horizontal velocity and constant vertical acceleration. The kinematic equations are equation horizontal vertical, and then acceleration equation when it is horizontal, and then ax equal to 0, and then vertical ay equal to minus g. And then velocity time Vx equal to V0x, and then on the vertical position Vy equal to V0y minus gt. And then displacement time, velocity, displacement, all things like those. Horizontal range. The horizontal distance travelled by a projectile is called its range. A projectile launched on level ground with an initial speed V0 at an angle theta above the horizontal will have the same range as a projectile launched with an initial speed V0 at 90 degree minus theta. Identically, projectile launched at complementary angle have the same range. Will have a maximum range when theta equal to 45 degree. Thank you to one and all.